I'm Shane, and today we're going to take a look at rolling objects and the moment of inertia. I have these two long bars that are attached to a center pin. Now both of those bars are able to rotate around this position. So what I want to do is I want to attach this to a table. We're going to lift them up and release them and observe what happens. Now gravity is applying the same force to both weights. As we clearly see, the object closer to the center of rotation will accelerate quicker around its axis. Now let's apply this to objects that roll. These are two standard objects that are sold by science companies. We see that the one that has more mass in the center rolls a little bit quicker. I want to add a third object here. The ball has more of its mass towards the center than the cylinder does, so it's going to accelerate even quicker. Here are a few homemade pieces that share the same principle. They weigh the same, only the mass is located at different positions. I think this one shows it the best, so let's try it. Now if I want to feel this moment of inertia on a large scale, I have these two wooden blocks attached to this meter stick. And if I hold it here in the center, I can turn it back and forth very quickly. It doesn't require much effort. But I want to move the blocks to the outside. Go. Tighten them down. Now in one rotation, these blocks would be covering a much bigger circle, so I've increased the moment of inertia. Now if I try and turn it, you see it going much slower. It's much harder to turn. It requires more torque simply because I've increased the distance that they must travel as I rotate it around the center of my hand. Now let's apply that to our rolling objects. Mass on the inside, it's going to accelerate quicker. Mass towards the outside, harder to turn, it has a greater moment of inertia. So that's what's going to happen with these other objects. Mass towards the outside, it's going to be harder to turn it because it has to move at a greater distance. So if we put more of the mass towards the center, it doesn't have to turn it as far. This is even more mass towards the inside. And if I want it to go as quickly as possible, I want to try and get as much mass turning as little as possible. So one last race. Let's try these two together.
It's really the conservation of angular momentum that's really important here. I have this flashlight rotating. In physics, this angular momentum of an object rotating about some reference point right here in the middle, that's a measure of the extent to which the object will continue to rotate around that point unless it's acted on by an external torque. I can demonstrate this to you with me actually doing a little bit of a demonstration here. So I want you to watch this. I'm going to have to unclip the microphone or I'll tie myself up in knots. Again, what's going on as my body spins doing this and moving my arms in and out from being close to the body is when I bring the arms in closer to the body's rotational inertia is decreased. The angular momentum must be conserved. As the rotational inertia is decreased, the angular speed increases, and vice versa.